So question 17, part C3, which we were discussing, that how we can write a combined equation as we want a +6 disproportionation, means we want a +6 to increase in oxidation number and we want a decrease. So here Mn is +6, here Mn is +4. So this is a reduction. And here Mn is +6 and this one is +7. So if we read, the forward equation is reduction as well, but backward is oxidation. So we want to write a combined equation for these two. So we check the one which is having a higher electrode potential. So that will be reduction will happen. So the second one, oxidation will happen. And the one which is reduction happen, we write equation as it is. We won't change. We won't change. But the other one, because oxidation happen, which is a loss of electron, so the reactant will be a product and a product will be reactant. Means what will be the new equation? It will be MnO4 minus 2. That will be MnO4 minus 1 plus E. We just switch the reactant with product. And then what we do, because we want to add the two equations, so we multiply this equation by 2. So we'll have same electrons. And we simply add the two equations. When we add 2 plus 1 make 3 MnO4. Because this will be 2H2O. Electron will cancel with electron. This will be MnO4 minus 1 is there. So 2 MnO4 minus 1 plus MnO2 plus 4OH. So that is a combined equation which we need, and it's of only 1 mark. The next one is the part 4, standard cell electrode potential we need when MnO4 is reacting with hydrogen peroxide. MnO4 with the charge. So MnO4 is reacting with hydrogen peroxide. So we mark those reactant. MnO4 is this and hydrogen peroxide is this. Now the one which is having a higher electrode potential, so reduction happen. Because if we need the cell voltage, it is redox, means reduction minus oxidation. And in the products, what we have, in the product we have Mn plus 2, like MnO4 changes to, so which equation is having? So we have this, and we have a hydrogen peroxide. These are the two reactants. And but this one, hydrogen, because electrode potentials are always given for, if we use this equation, what is the second reactant? The second reactant is for hydrogen peroxide. These hydrogen peroxide are there. Sorry. So if we use this equation, for example, if we use this one, then what should happen? Because in these two equations, this should be reduction as it's a higher electrode potential. So this will be oxidation. Means according to this equation, hydrogen peroxide will be reactant and water will be product. But according to second equation, Mn2 will be the reactant because it's oxidation. So this will be reactant and this will be product. But we want the equation in which MnO4 minus 1 and hydrogen peroxide both are the reactant. So it means this is not the combination we select. Then what else is there? This is MnO4. And there's also another hydrogen peroxide is there. If we check this equation, like their electrode potential, so this is a higher electrode potential, reduction and oxidation. So means this forward reaction is feasible and this backward reaction is feasible. So in this way, this will be the reactant, and this way, this will be the. So hydrogen peroxide and MnO4 will react in according to these two equations. And what is the cell voltage? How to work out the cell voltage? Reduction minus oxidation. So 1.51 minus 0.68. Because It is red minus ox, which is a redox reaction. So it will be 0.83 and the unit will be volts. Is it clear? So we check because the two equations involve hydrogen peroxide. If we use the first equation, then hydrogen peroxide will be reactant, and instead of MnO4, it should be Mn plus 2 should be the reactant. But as we select the another equation, according to that, hydrogen peroxide and MnO4, a manganate ion, is the reactant. Draw fully labeled diagram of the apparatus you would use to determine the standard electrode potential of a dichromate 6 and dichromate and chromium 3, because here the oxidation number is changing. So we like it's not forming the element. So we don't need the electrode made up of chromium. We can use an inert electrode, but we need the concentration of the solution should be same. So if you want to draw the cell, so we have platinum, and that is dipped in a solution of 1 mole per dm cube solution of a hydrochloric acid. And it's connected to a very high resistance voltmeter. Because the cell is changing, like the electrodes are, there's a change in oxidation number, but it's not forming chromium metal. So we don't need here. So this should be platinum. This also platinum. Hydrogen will be bubbled here at 1 atm. Salt bridge will be there. And this solution should be 1 mole per dm cube, which contain both chromate ion, dichromate ion, and chromium 3 ion. Both should like, and it should be acidified because in acidic condition it happened. So it must be acidified. But the total concentration for each of them should be in this manner. In part D, the mass of ethanol is 5 cm cube in a white wine is found by oxidizing the ethanol to ethanoic acid using acidified potassium dichromate. 5 cm cube of a white wine was diluted to 100 cm cube, and then only 10 cm cube of acidified potassium dichromate of concentration was placed in a conical flask. Dilute wine are left until the ethanol has been completely oxidized, and 10 cm cube of potassium iodide solution was added to react with the remaining of potassium dichromate. The iodine produced was titrated with 0.03 moles of thiosulfate. The procedure is repeated twice more. The mean titer of thiosulfate was there. So dichromate to ethanol reaction is there, and chromate to chromium 3 conversion when it is reacting with iodide ion, and iodine molecule to thiosulfate is there. Use the equation, determine the mole ratio of thiosulfate into dichromate in this series of reactions. So how we can work out thiosulfate to iodine is what? 2:1. And then iodine into chromate is what? 3:1. Like if we simply work out the series of reactions, 2 moles of thiosulfate react with 1 mole of iodine. And that 1 mole of iodine react with 3 moles of 3 moles of iodine reacted with chromate. So if I replace here because what will be the simpler, like for one molecule required 3 iodine and 1 iodine required 2 thiosulfate. So what we, like I can simply replace here with 2 thiosulfates. So I can say as we have S2O3, the thiosulfate, 2:1. And the ratio of iodine to chromate, or sorry, dichromate is 3:1. We need this relation. So if I multiply this by 3, so I will get the same ratio, like this will be 6 and this will be 3. Now I know like 3 iodine required 6 thiosulfate and 3 iodine required 1. So what will be the relation between the thiosulfate and the dichromate? So 6:1 will be the ratio. Because like if 2 required 1, so 3 required 6. And so 6 thiosulfate will react with 1 mole of chromium dichromate. Calculate the mass of ethanol in 5 cm³ of original white wine. So we have to use these series of reactions to work out the original amount. So first, this is always done in a reverse manner, like how it will be done. As we have the mean titer and we have the concentration, we'll get the moles of thiosulfate. From moles of thiosulfate, we'll get the moles of iodine. From moles of iodine, we'll get a moles of you can get chromium as well directly. And from moles of chromium, you'll get the moles of ethanol. So first part, we'll get the moles of thiosulfate, which is concentration 0.03 multiplied the volume. The mean titer was 9.2 cm³. We divide by 1000. So we get 2.76 into 10 to the power minus 4 mole. These are the moles of thiosulfate. And we already know like how many, because thiosulfate to chromate, the ratio is 1:6. So thiosulfate 6:1. So you can do first get iodine and then dichromate, but directly it can also be done as the ratio 6:1. So this was 2.76 into 10 to the power minus 4. So this will be X. Cross multiply. This will give us how many moles of a chromate are left, because we are reacting with the left moles. So it will be 1.38 into 10 to the power minus 4. These are the moles which are left. Moles left for dichromate, Cr2O7. Because the unreacted moles were reacted with first iodine and then iodine is titrated with thiosulfate. What was the original, the total moles which we used for the experiment? It was, this is 5 cm³. This was acidified 10 cm³ of dichromate solution with a concentration 0.01. And this was 10 cm³. So how many moles were there? So 0.015 multiplied by 10 divided by 1000. This will give us the total moles of dichromate which were added to this wine. That will be 1.5 into 10 to the power minus 4. Then how many reacted? So 1.5 into 10 to the power when you solve this, this answer was 4.6 into 10 to the power minus 5. When you divide it by 6, you will get the answer. 4.6 into 10 to the power minus 5 moles. So these are the moles which are left, and this is a total moles we use. So how many moles are reacted? So 1.5 into 10 to the power minus 4 minus 4.6 into 10 to the power minus 5. This will give us 1.04 into 10 to the power minus 4. These are the moles which reacted. Now, how much 10 we distill and 1 cm cube of a wine was used. So how many moles are there in 1 cm cube? So 1 cm cube of a wine, how many moles are there? As the ratio, how many moles of ethanol? The ratio is 2:3. So 2:3 is there. So if we have 1.04 into 10 to the power minus 4, so this will be x cross multiply. This will give us the moles in 1 cm cube, which is 1.56 into 10 to the power minus 4 mole. And then the original, because originally how much, what was the total? 5 cm cube of a wine, it was distilled to 10 cm cube. So, and we took out from 10 cm cube, we took out 1. So the original will be 10 times, like the number of the moles in 10 cm cube will be same as in 5 cm cube. So the how many moles will be there in 100 cm cube? So that's why we multiply this by 100. So we get 1.56 into 10 to the power minus 2 mole. So these are the total moles, but what is the mass of ethanol? We multiply by molar mass, which is 46. So we get 0.71 grams of ethanol is present in the original wine. So 5 cm cube of a wine, we dilute it to 100, but they will have the same mole. Only we add water dilute. And out of 100, we took only 1. So that's why this last answer, first we multiply by 100 and then we multiply by the molar mass to get the final mass of the ethanol present in the wine. So this was questions 17 from the exercise electrode potential and the transition matrix.